This is Dr. Holt. This video is on understanding basic position versus time graphs and velocity versus time graphs when given an acceleration of 0, and determine the relationship between the velocity versus time graph and the position versus time graph. Here I have an object. It's going to start at a position of 10 meters. It's going to travel at a constant velocity of 5 meters a second for 14 seconds. To start, we will draw the velocity versus time graph first. So right now I have both graphs. I have my position versus time graph, my velocity versus time graph. First thing we want to do, we want to label these. I put my first label here. On the vertical axis, I'm going to put my velocity. I'm also going to put my units in meters per second. On the horizontal, I have my time here, and I'll put my time units as seconds. I'm going to go ahead and label my position versus time graph, put my position on the vertical axis, and my time. All right, what we want to do here is to use the most of the graph as we can. Here I'm going to be a constant velocity of 5 meters a second. So what I did was, instead of letting each tick mark be 1 meter a second going up, so it'd be 1, 2, 3, 4, 5. If I did that, I'd only be using this part of the graph. So I went ahead and let each tick mark here equal to 0.5 meters per second. And to do that, if I count up now, I will get this mark right here to be 5. And I don't put the units on here because I already have a meters per second here. For the time, I've gone ahead and identified each tick mark or each vertical line here representing 1 second. So at the end, I will have used the entire 14 seconds. When you're setting up your graphs, go ahead and use something that's more convenient. Like I would not let each tick mark represent like 0.3. Try to do something that's in units, so you get something that's going to give you in units as something that's reasonable. All right, so I have my velocity versus time graph drawn. Again, it's going to be constant. It's going to have a slope of 0 because of no acceleration. It's just going to be a straight line all the way from 0 to 14 seconds with a numerical value of 5. All right, now let's talk a little bit about what this area is under here. And I'm going to go ahead and shade in this, and we'll do this with a purple. This area in here underneath the velocity versus time graph. Again, I'll just shade this in best I can. It doesn't have to be perfect, but I want you to understand what this is. Okay, all this area in here is called the displacement. And let's go ahead and write that in here. This area underneath here is called the displacement. And I have a rectangle here, so to find the area, I will take the 5 meters a second, I will multiply it by 14 seconds. 5 times 14 gives me a value of 70 meters. So I will label this as this displacement is 70 meters. What does displacement mean? It means from where I started, I am 70 meters, and it's all positive, 70 meters from where I started from. So since I had a constant velocity, my distance traveled in this case is going to also be 70 meters. So I have traveled 70 meters in the first 14 seconds. Okay, from this information, we are going to be ready to draw our position versus time graph. Now we know in drawing the position versus time graph, we know we started at an initial position of 10 meters. All right, so I came to my position versus time graph. Again, I want to do something that's somewhat reasonable. I'm using the same horizontal scale, meaning that each tick mark here or each vertical line is going to be 1 second. And over here I have 14 seconds. Again, I'm using the entire part of the graph when I go horizontally. Now to do the vertical, I know that 5 times 14, as I mentioned before, is 70. I'd add that to 10, it would be up to something like 80. Now, if I let each of these represent say 5, so I'd have 5, 10, 15. I would be outside of my graph, so I want to step down to something that's reasonable. So I decided to let each horizontal line or each tick mark represent 10. So that'd be 10 here. I'd step up another one, 20, 30, 40, 50, 60, 70, and 80. I come along here, I put a dot right there. That represents 80. Now, if you want to know where the 80 comes from, all I've done is I've taken my initial position of 10, let me circle this 10, and I've added back to my displacement. I've added the 70 back to that. So that gives me 80. So 10 plus the 70 is 80. I put the little mark here. This horizontal line represents my 80 meters, and I draw a straight line between those 2 points. Put the points in here. Straight line between the 10 and the 80. Okay, it's going to be a straight line, not going to be a curved line, it's a straight line. The reason it's a straight line is because your velocity versus time graph has a slope of 0. And I'm just going to label that. You can see this has, we'll put m as slope is equal to 0. I have constant velocity of the 5 meters a second here. Alright, so this is my position versus time graph. So again, let's talk a little bit about this. This area here represents the change from here to here. Okay, so again, we calculate that area. I want to make sure you completely understand. It's 5 times 14, we said, was 70 meters. I've added 70 meters to my 10, so I go up here to my 80. This distance right in here during this 14 seconds represents this entire area here. All right, what is the relationship between this velocity and this line? Well, that's the slope. And let's just verify. Now we know that slope is equal to the change in my vertical position divided by the change in time. Or for mathematical, you probably used to y2 minus y1 divided by x2 minus x1, and that's basically what we're doing here. So let's calculate what my slope is. I'm at 80, so I take my 80 meters, I subtract my 10 meters. What is the change in time? Well, 14 seconds here. I subtract my 0 seconds here. Okay, and what do I get? 80 minus 10 is 70, and 70 divided by 14 is equal to 5 meters per second. Well, that is my slope. Well, my slope isn't my slope exactly what the velocity value is here. So this value right here, whatever your velocity is going to represent the slope value of your line right here. So again, let me just repeat. The slope of your position versus time graph here is the velocity during that same time interval. Alright, so that is the relationship between a velocity versus time graph, being that the area under, I'll repeat one more time, and you're probably getting tired of this, but I want to make sure you understand it, that the area under a velocity versus time graph is the displacement. That will tell you the change in your position during that time interval. The numerical value of your velocity tells you the slope of your position versus time graph within that time interval. Again, I hope this short video helps you understand the basic concepts of the relationship between a position versus time graph and a velocity versus time graph. Best of luck.